Hello everybody, it is Mike Levin on Sunday, July 19th, 2020 at around 10 p.m. and I am here driving through glorious Newark, and if you're lucky you'll see a little bit of Manhattan through that window there as I drive. Probably not, I'm probably a little too far by now, but I'm heading my way back out to the Poconos. I am now the Poconos Pythonista, and I'm thinking about what to talk to you about today. And of course it always ties back somehow or other to what I'm doing at work. And I am 49 years old, going on 50 this August, and I of course am prompted to think a little bit about, my life. Midlife crisis? Probably not. Got that out of the way a while back. But I guess sort of came to the conclusion that while I have not gone the blockbusters financial success and having saved up lots of money like probably a lot of my contemporaries at this time have done, I have invested in myself, invested internally, and happened to have all the right skills at the right time for the way the world is moving. Not to say I'm a master of any of these things like machine learning. However, I have done quite well at all the prerequisite work to things like machine learning. The where to get the data, the how to get the data, the what data to bring down, dealing with warehousing data, long-term warehousing issues, when to, when not to, transforming data in all sorts of ways. And in the past, I was quite enamored with the first of the viable data transformation languages that really came across my awareness, things such as XSL. So, for fear of jumping into one of these alphabet soups, technology always has downsides. And it being very tied to platforms and periods of time is one of the biggest pitfalls. So you get yourself in these situations where all the skills you've acquired and built up are tied to a particular time and place in history, and you have to retrain and relearn, and I've fought against that effect a lot. And one of my early attempts to fight against that effect had led me to XSL, or XSLT, which is XML Style Sheet Transformations. It's a mouthful to say using XML to change one XML file, which is basically structured data, into another XML file, which is basically structured data of a different structure. That's the transform, that's the T in XML Style Sheet XML Style Sheet Language Transformations. That's the T in XSLT. And I had done some really wonderful stuff with that tech, like pulling down data from almost any source and then slicing and dicing it into web pages and then stylizing those web pages into any look, before the days of CSS when you could do this through much more separation of concerns ways. It used to be all your HTML code was kind of intermingled with everything you did to make the page look good. There was a lot of table manipulations, the table tag, the TD tag, and the TR tag for rows. But those days are kind of long ago, and they've moved on to better web development techniques, mostly having to do with CSS, cascading style sheets, and it's completely taken the place of having to do the stylizing in the HTML code itself. XML had taken a pretty hard hit when JSON, JavaScript Object Notation, busted onto the scene, because JavaScript was used for so much front-end web development, and then when Node.js came on the scene, JavaScript was used for so much back-end web development that the very competent language for managing data, for mostly transporting data, the JavaScript Object Notation, JSON, that's the stuff with the curly brackets with a lot of colons in there, with a lot of name-value pairs. Well, that had taken away a lot of the thunder from XML. Just when electronic data interchange became down into the realm of people like me, not high-end e-commerce people, but jack-of-all-trades technologists, we got pretty adept at things having to do with XML, but JSON busts onto the scene and everybody starts to take up JSON. And this thing called the RESTful APIs, programming interfaces, application program interfaces, RESTfully, to take the pressure off of you. It got rid of standards like SOAP and let's see, there's a whole bunch of technology out there that dealt with the electronic data interchange problem, but it made it too complex. SOAP jumps to mind. It was built into a lot of Microsoft serviced, ASP.NET stuff. A lot of .NET stuff used SOAP. But then this technique called RESTful came onto the scene. RESTful was first applied to XML, but then later it applied to JavaScript as well. And so the way people shot data around to each other greatly became these text files that looked a lot like JavaScript, but just extracts of the data portions called JSON. So that brings us much to where we are today. However, the data transformation languages that I use turn out to be a combination of just Python, because Python is not going obsolete. It's just getting more momentum all the time. And hand in hand with Python, the Pandas Library. Now more and more it's Pandas plus Xarray to handle a different kind of data. But so long as your data structures are intended to be tabular, that means rows and columns, a lot like Excel, a lot like SQL Server tables, then Pandas is your poison. And all your data transforms are just things you can do in combination between the Python, native language, and the Pandas package API extensions to Python, because that's what a package often does. It just extends the capability of the language and adds to the interface. Anyone who's familiar with Pandas knows that it's not just plain vanilla Python, but they have their own notion of slices. Things that are in square brackets in Python become not in square brackets in various cases in Pandas. I suppose just to reduce the amount of typing for very common tasks. But you go through the .loc and the .iloc methods to do all this rowing, column, slicing, and dicing. And you can use it in combination with all kinds of other operators to take data from some source, do things to it, and put it into a destination, often as a report that you're passing along to some stakeholder so that...
In 2 miles, use the left 2 lanes to take the I-80 West exit.
Business decisions or whatever. So when you go researching what's hot right now, you're going to find a lot of keywords, a lot of machine language stuff, a lot of libraries like TensorFlow, and a lot of technology infrastructure things like Docker and I believe it's called Kubernetes to rapidly deploy and Docker images. There's a whole, there's endless things really there to be learned and mastered, but that is the very problem. Who wants to continuously learn and master new things just to stay competitive, just to keep your head above water? So what you're really doing is you're learning and mastering those key things that you can get a good 10-year run out of, and that stages you for learning and mastering the next tangentially related.
In half a mile, use the left 2 lanes to take the I-80 West exit.
Foundation, and the giant reset button is not constantly hit on you. So when I switched from XSLT to Python and Pandas,
use the left 2 lanes to take the I-80 West exit.
The reset button was pressed on me because the mental model of how XSLT does its transforms, the rules that it follows,
continue on I-80 West for 47 miles.
Are so unique and novel that it's its whole own bizarro world. You have to really understand nesting and nesting termination and how objects get walked, and it was a real mind bender. I'm not unhappy to leave that behind. Although it was a really nifty language for both data transformations and web development. It lived in this very interesting place that really demonstrated to me that these worlds are often not as different as they seem at first. Okay, so that brings me to where I am today, and I have Python pretty firmly committed to muscle memory. I'm doing Googling and referring to GitHub less and less to just naturally express myself in Python. It just rolls off my fingers as the words roll off my tongue. I'm about as good of a Python programmer as I am a speaker. That's not to say I'm superb at it, but I get my point across, and I, with a little bit of vision and a little bit of revision, can do pretty much anything I set my mind to. However, I don't like to set my mind to things that incur long-term tech liabilities. So, databases, for example. One of the first things to come up in almost any project, because, the flow goes like, you pull data from somewhere, you're going to do something to it, you're going to put it somewhere, but where do you put it in the meantime? How do you pull it down? Do you keep it long-term? Do you keep everything you fetch? Is there advantage in that? Well, the answer is oftentimes there is advantage of it, and you can do all kinds of trending work when you keep all your data that you pull down. However, it's a terrible tech liability. You become a slave to your data. You become a slave to process. And more over the years, my methodology has been to use less formal databases. Many of the things I can do would absolutely benefit from having a bona fide SQL server on hand, even SQLite that's built into Python, but I tend not to use it. Key value pair databases like DBM that's built into Unix and Linux, and I am kind of using that because I'm using things that are built into Python standard library as just a standard part of the language. If you wanted to use SQLite, which is built into Python, you would have to do a fair amount of off the beaten track coding to be in SQL land. You know, SQL has its whole own set of methodologies. But if you're just in key value pair land, hashtags, you know, all data, Python has a built-in data structure called dictionaries, D-I-C-T, dict, and those are key value pairs, and they're fast lookups. Some languages call them hash structures. Some languages call them arrays. There's a lot of ways to look at it, but basically you put some value in and you get some other value up. It's just a lookup table, and they're highly optimized for speed. Many database operations or needs follow that model. It's just that the stuff you put in and take out has persistence. It lasts for more than just your one programming session. If you're doing it in a way that it all has to just occur in memory, and the data you fetch, it needs to be accessible through a hash, you can use a dictionary in your code, and when it's over, your data's gone, except for what you explicitly output to maybe a CSV file or something. But if you wanted to keep it, you can simply use Python's built-in pickling method and its higher abstraction level shelf method, so you don't even need to think about pickling. And your key value pairs just become persistent by having to choose a file name and having to use with open and a file handle representing that actual file name, and indenting everything underneath of that, and that opens a file. It writes your key value stuff right onto the hard drive or whatever storage your system uses, and it's persistent, and you can fetch stuff out of there by reversing the process and pulling the stuff out of the shelves, and you can check whether things are in there before you put stuff in to prevent, you know, overriding. So a lot of what we call NoSQL these days is just built into Python in a a small scale way. And if you wanted it to work in a big scale way, generally you can swap out what backends your key value pair stuff, your dict, your shelves. So if you're using a dict or a shelf and you want to go big time, you can just backend it with Redis, one of the key value pair databases out there, or even Postgres, which, although is SQL and generally you're inclined to work with rows and columns, tabular data, different than key value pair. If your rows and columns are really just two columns, one column for key and one column for val, it's key value pairs. And the performance of such databases as Postgres is that you can use that as a very competent key value pair database. So you have lots of options. Mongodb is another option, but the API sort of changes. Whereas the simple Python API of stick a key in, get a value out, that's great. But say you wanted to search across all the values that are in for every key, and suppose you want to search across all the values, treating it as if it were structured data, so that because the value that would come out is a giant JSON object. So MongoDB, CouchDB are different databases that are out there that do exactly that. They're NoSQL key value databases, but the value that comes out is expected to be structured JSON data, and you really want to search against that, not against your keys. So indexes are built if there's any sort of reliability of the data structures that come out of your key value pair. So anyway, there's lots of database options, and no matter what your task, there's a database right for you. However, the database that's right for me in most cases is no database. I like to program things so that they're like phantoms in the night. They come and go on their schedule. They do what they're supposed to do. They fetch the data from where they need to fetch it. They push the data to where it needs to be pushed to. And that script, because they are scripts, Python's scripts, has no other real side effects. So I don't have any tech liability other than keeping that script running. It's a personal preference thing. It's a career choice. It makes me good at pulling off some miraculous feats, pulling certain rabbits out of my hat, and kindly declining to attempt to deliver other miraculous feats and not being able to pull out certain other rabbits from my hat. Now, I developed this attitude really before the cloud had matured. There were a few options back as this phantom in the night, this monkey in the middle methodology had taken form in my head. Those things were Amazon S3, a very competent, very, very deep key value pair database. And I always figured if I did go that other route of incurring tech liability, it would certainly be on Amazon S3, a giant bit bucket. Now I know different because lots of other cloud platforms had been maturing at the same time, a little later to the game, but Google bought one of them called Firebase. So if you hear Firebase being used as like a multi-platform application platform, a multi-mobile platform application development platform, I guess that's true. However, one of the most important and definitive bits in that is a giant, deep key value pair database along the lines of Mongodb, where it's intended to have your values that come out as searchable JSON. So these are real hybrid databases. It's a pretty neat trick. And if I were to incur the tech liability of a database these days, I would really think carefully about using Google Cloudflare. I see, it's not Cloudflare, it's Firebase. Cloudflare is something completely different. I would look long and hard at using Google Firebase. I see my peers at work using it to great effect, taking on the tech liabilities that I am very hesitant to do so. Everything that you keep running that requires finding something somewhere and using some code to run something adds brittleness to your app. It adds moving parts. And I just don't like doing that. I think Python is a competent enough language that for the most part, all the moving parts you need are the code that's in a single repository under a version control system, usually Git, usually in private repos in GitHub, now owned by Microsoft. You can see that a lot of the fundamental ways of working have been, snatched up here and there by different vendors. Google got Firebase, Microsoft got GitHub. Nobody owns the entire picture to do everything in, whatever way you want. When you choose a platform like the Google Cloud Platform, you're choosing the services they offer. You're choosing their ecosystem. And while you can create hybrid solutions using multiple cloud platforms in conjunction, it's just all the more moving parts and all the more brittleness and fragility to your application. So I like to make a script that can run on any Unix/Linux host. Oftentimes it's Amazon EC2, Amazon Computing Cloud, but it can just as easily be Linode or any other, cloud provider, or your own hardware. It could be a Raspberry Pi. You could bring it in-house. You could run your own Blade server. The point is it's generic. It's Nix generic, right? So when you choose who and what to align yourself with, you have to decide what your criteria are on that alignment. Being able to build powerful apps quickly would be a cloud alignment like Microsoft Azure, Amazon, AWS, they call it under Amazon. It's a whole grab bag of services. On Google, it's Google Cloud Platform. But there is another that is non-aligned. It's just generic Nix platforms, Unix, Linux. And you would say, well, maybe it doesn't have everything. Well, in a pinch, it has almost everything you need. You can install Redis, you can install Mongodb, you can install all these different flavors of Postgres, of different databases, free and open source databases to get exactly what you need. You can run it on your own hardware, you can keep it private if you wanted to, and you could have maybe not all, but many of the same capabilities that these cloud platforms provide. You just incur now the system administration, the network administration, so you always pay for it somewhere. However, because you know how to do it generically, you're not beholden to any vendor, and no one can take it away from you. No matter how things change out there in the marketplace, your skills cut across time and space. You could walk into any company under any situation, and your knowledge is always applicable, relevant, and useful. I might add that all these cloud platforms do also strive to offer generic Nix capabilities. You would call it infrastructure as a platform, IaaS. There's all this AAS as a service, infrastructure as a service, IaaS. There are platform as a service, PaaS, software as a service, SaaS. But the one that is of most interest to me is IaaS, infrastructure as a service, because you can use the cloud and you can deploy 1,000 instances of something. It's just you're not insulated from the grisly details of it. And the way they all insulate you is also going to change over time. Heroku was the big thing for a while because they found a neat way to offer you that kind of scaling invisibly. Amazon did it early with Burst, Burst servers, and load balancing plays into that because you would need load balancing so that your Burst servers could be hit against without your application needing to know that it's even doing anything fancy. However, now there's things like just developing web services, web functions from the Google Cloud Platform. There's this name salad going on. Everyone tries to make grabs at this word real estate. Microsoft did it with web services. Google's now trying to do it with cloud functions. And it's all the same stuff. They're just rejiggering what down underneath is just infrastructure as a service. And they're putting different APIs, different application program interfaces on it to make it easier for you as the developer, and hopefully from their standpoint to lock you in, to make you dependent on these simplifications they've provided. So I don't play that. I have almost like an allergy to the feeling of vendors trying to tease you into these dependency situations. Azure is the big one right now. It's growing like gangbusters because, Microsoft just solved one of the biggest pain points in tech, that standard development, i.e. being on a Nix platform, was nearly impossible on Windows. You had to use all these things like Cygwin and other approaches to getting a Nix environment on your Windows machine. Now, once you did it, especially with Cygwin, your machine was more Unix/Linux compliant than even Apple, which is built on it, or even Linux for that matter. So there's something called POSIX compliant. There's a bunch of other ones as well, but it's the degree to which your Nix platform provides the same services that some organization decided was what Linux or Unix should be. And it really dates back, one of the granddaddies of all of them was AT&T System 5 Release 4. It's when all these rogue versions of Unix sort of banded together and said, okay, this is the standard. Our Unix is also compliant with System 5 Release 4. And we still feel the results of that today in things being SVR4 or POSIX compliant. Linux generally is not, because, it depends what Linux you're talking about. The massively popular ones these days, because Microsoft has teamed up with Canonical that makes Ubuntu. It uses the Debian Package Management System, the Debian Package Management System. I always forget those initials, but people use apt-get all the time. I think there's also a desktop app called Synapses. But at any rate, because it's not using Red Hat's ye old RPM for package management, remote package management, Red Hat package management, RPM, also known by a lot of Nix people out there as Yum, the Yum package management. That's the compliant one. It dates back to a Linux that had the power of IBM behind it. But Debian didn't like that. They went their own way. And when they did it, it was in order to resolve dependencies, which was one of the biggest pain points on Linux. When you couldn't just install software. There wasn't like store-bought software that you just bought and popped a CD in and hit an installer. Rather, you had to download the source code, compile it, and when things relied on each other, you got into this place called Dependency Hell. And the Debian package management system, and Debian as a Linux distro at all, came into existence to deal with Dependency Hell. And they ensured that every piece of software could interact properly, could install properly, and have their dependencies resolved. So since those days, the IBM, Red Hat, Mandrake camp has completely caught up, and using the Yum installer will resolve your dependencies just like the apt-get installer. But one is POSIX compliant and the other is not, and I guess it really doesn't matter all that much, except for the fact that there is this concept of generic Unix/Linux out there, and it's really good to know. And a lot of the pain points have been removed, so it's not that much harder than your Mac and Windows platforms. It might look that way, it might at first feel harder because you're using the command line interface a little bit more, but it's just like anything else. After a little while it gets easy, and then it's second nature. And the things that would normally be showstoppers, it used to be you get into your little text interface and then everything becomes difficult because you're doing something like resolving some dependency on an install. With those problems gone, the type-in interface is a lot more pleasant and indeed powerful than it once used to be. So everything old is new again, and old school is cool. And underneath almost every system out there, you're going to find this Unix or Linux underlying system. There's probably a Linux kernel there that's getting the whole system booted and run up, and then it might be handed off to something custom. But fact remains, you as a developer can control that hardware by stepping in and taking control of the boot process. This applies to Macs because they're standard Unix for the most part, derived from ye olde Unix, the ivory tower stuff. It's derived, I think, from one of the Berkeley Unix kernels, which makes it kind of special. One of the last real Unixes left out in the marketplace, or that ever made it out into the marketplace in the mainstream. But your standard Windows machine now, since the May 2020 update, ships with a Linux kernel, and you can get Linux running on your Windows machine very easily. It's not what gets the machine running, but give it time. Microsoft sees the writing on the wall, and they're jumping on the bandwagon just like everyone else. They haven't bought Canonical, who makes Ubuntu, but they may as well have. You think Ubuntu has any bigger customers than Microsoft? They're just an arm of Microsoft now. So Microsoft has their plans to finally switch from proprietary to more free and open source. There'll always be proprietary bits sprinkled in. There is with everything, because custom hardware, custom drivers. So your Macs are Unix, your Windows now have Linux, your iPhones, Unix, your Androids, Linux, your Raspberry Pis, true Debian. I mean, it might be some custom stuff on top. I don't know. I don't know if they don't even call it Raspbian anymore. But they've been advancing their own branch of something that was derived from Debian, so it's in the same camp as Ubuntu. Raspberry Pi is the little $35 computer, or $5 computer if you get the Raspberry Pi, I guess it's Zero they call it. It's all the same stuff. Probably half the, embedded systems out there, a developer could take control of by just connecting through serial connection to it. And there's other stories here. Everybody knows how to get to stuff by sitting down at a computer and getting to it through a web browser or some other piece of software that lets you connect into something. Well, that thing that lets you connect into something doesn't have to be internet. That's just what's become massively popular lately. But it can be a cable connected directly to a piece of hardware. That's called a serial connection, usually through serial ports. And a lot of devices that are not even networked or connected to anything, you can plug in directly and get that same Unix/Linux terminal prompt as you get by opening up the Macintosh terminal, and now the Microsoft Unified Terminal. Anyone now who's interested in getting into the Unix/Linux world and is on Windows and who has the May 2020 update, you can just download the terminal shell, the Unified Terminal shell from the Microsoft Store, and it, of course, gives you the standard Windows COM that we all know and hate, with its :/. And it also gives you PowerShell, but it also gives you a standard Ubuntu Bash shell. And people who want to get into Unix or Linux should get into it through that, because you can do it on your own machine. You don't have to connect into anything remotely. But the things you learn let you connect into remote things. The things you learn let you connect into local hardware connected through direct serial connections. In other words, it makes you very, very powerful. It makes you able to talk to machines under almost any circumstances. It's not the technology of the thing. It's not the hardware and the way it's put together that is a barrier. It would just be security and permissions. And that's a nice place to be. It's only ever securities and permissions that keeps you from sitting down and working on a piece of hardware. There are often certain magical incantations to get a piece of hardware started in the first place. You sometimes need their original install disks and such because custom binaries. But they all basically use a very similar trick of starting to read something off of a privileged known location, piece of hardware, place in memory, which then hands control over to something else, which then hands control over to something else, and eventually you've got a fully booted system. And so long as you have that initial magic key, that magic incantation, the install disk with the custom drivers on it, the custom binaries, you can figure out what it's doing and step in and take control at an early point, and then you have a Sorcerer's Apprentice broom under your control. And, well, you know, what more can I say? I think I got the point home. I've talked for almost 40 minutes about my philosophy and methodology towards tech and taking up tech projects and resisting obsolescence, and how old school is always applicable and always interesting and easy and learnable and committable to muscle memory, and doesn't put you at as much of a disadvantage versus the cloud people as you might think. However, I would always suggest to still take up something like one of the cloud platforms. Just as I suggest that if you're into mobile, take up mobile app development using all its, almost by definition, platform and vendor lock-in stuff that comes with it. If you're doing iPhone app development, your two software languages are Objective-C and Swing. I mean, talk about platform lock-in, classic Apple. If you're on Android, if you're doing Android mobile development, that language is Java. And, contested, intellectual property contested, non-standard, well, I guess standard by virtue of being so popular now, but it's certainly not the people who invented Java. They have lawsuits with the people who turned Java into a platform for Android development. Oracle, which bought Sun, now owns Java. And the Java that is used for Android development, I forget its special name, but it's one that was kind of black box engineered because Java is supposed to be a free and open source protocol, if not the implementation. That's often the case. Down underneath, there's a custom implementation that is proprietary, compiled for optimization. But what it's doing, the protocols and stuff, are free and open source. Things have to work a certain way or they can't be called Java, for example. That was an issue back when Microsoft tried to do a Java knockoff, probably as part of an embrace and displace strategy. But in one of those rare instances, Sun Microsystems at the time won a is it an injunction against Microsoft selling? It might have been J++, but a non-standard implementation of Java. So today, what is the Android development platform is one of those non-standard implementations of Java made by Google as the Android development platform. It's not the Java that came from Sun, now owned by Oracle. However, that's not the only reason to kind of wrinkle your nose at Java. It inherits all its syntax from C, which has all its syntax to make things easier for a C compiler. And this is where a lot of things like those needless curly brackets to delimit code blocks come from. And as the world advanced, things got easier and better ideas came in, so that instead of accommodating the machine with your language, the language accommodates the human. And a language called ABC came onto the scene, which was a student's learning language for absorbing a lot of computer science principles. And while ABC didn't go anywhere, Guido van Rossum took it up as the basis for the Python programming language, unifying it with the world of C programming by making anything you do in Python able to talk to compiled C code, so that C could be used for optimized bits of any Python project. They also made it very friendly towards sysadmins, so that a sysadmin could use the Python programming language as if any other scripting language like Perl, so that they could write their automated scripts more readably and more easily than they were previously doing in Perl. So Python created this amazing, Venn diagram of good for sysadmins, generally lazy and pedantic. Sysadmins, they want to set things up one way and keep it running forever that way. C programmers who can write really, really fast optimized code. You would be pretty hard pressed to find ways other than writing in the machine language itself, perhaps assembler, to write code that is faster than C. A lot of the native custom drivers and operating systems themselves are written in C. So the Venn diagram is the lazy, pedantic sysadmins, the C programming speed demon wizards, and the newbie learner. Because remember, it was based on the ABC programming language, a language designed specifically to be easy and fast to pick up and learn, and to learn good comp sci principles while you do. So that's the Venn diagram that made Python such a astounding powerhouse. Low barrier to entry, take you as far as you want to go with it, as it has become. It's what I use in my day-to-day work, and it's not perfect, but where it is imperfect, other people have come forward to reduce the pain. And the reduction of pain for the learner and for the person who wants to have all the power of Python locally on their machine and to do all the tricks that people are doing out there, need only install Anaconda. I repeat, need only install Anaconda. There are various roads to Python. It comes pre-installed on Macs. And on a Windows machine, all you need to do is hit the Windows R key, type the word Python, and it'll start getting it from the Microsoft Store for you. That is the latest and greatest Python from python.org, 3.8 something. However, unless you're ready to dive into the deep end, it's not as good as the giant massive Anaconda install, which allows Python to run in your web browser with Jupyter Notebook. So Anaconda installs a whole grab bag of stuff that's normally pretty difficult to install. And I sometimes say that JavaScript and other languages have Python envy on 2 points, 2 levels. One is Jupyter Notebook. The notebook environment for running Python code is so good for the newbie learner, but also really so good for the advanced developer who wants to feel out their code in a more early experimental phase than they might do in an IDE or a text editor, and they want to just sort of experiment freely. There's a lot of reasons that Jupyter Notebook, previously IPython, rocks. Even advanced developers who use IDEs benefit from Jupyter Notebook. So much so that Microsoft realized what a threat that was and decided to incorporate Jupyter Notebook right into Visual Studio Code, VS Code. Not the big grown-up version, not their IDE, not their Visual Studio.net, I guess it would be. I don't even know what the big version anymore, or if anyone would even use it anymore. But VS Code is the open source version that's based on the Google...
In half a mile, keep left at the fork to stay on I-80 West.
Right, so it's actually a web app, a fancy web app is Microsoft's now text editor IDE that's taking the world by storm. That
keep left at the fork to stay on I-80 West.
Now it doesn't work exactly like Jupyter Notebook, and the times I've tried to use
continue on I-80 West for 1.5 miles.
Has been
welcome to Pennsylvania.
Of a failure because it just doesn't feel the same. It doesn't have the Jupyter Notebook. Now Jupyter Labs. I've switched from Jupyter Notebook to Labs. It doesn't have the same feeling. And I guess it's also partially getting the heebie-jeebies of being lured into yet another text editor, when every text editor like that lets you down. Sublime, TextEdit, TextMate, PFE, Notebook++, Edit Plus. I mean, the list goes on. I could go on forever, but everyone has a favorite text editor they spent years and years investing in and using, and then just poof, it goes away. So the web browser isn't going away. Jupyter Lab isn't going away.
In half a mile, take exit 309 for US 209 North, Pennsylvania 447 North toward Marshall's Creek.
And my other text editor, Vim, isn't going away. It's been around since, in one form or another, since the rise of Unix, and it'll be around for as long as Unix/Linux is around.
Take exit 309, then continue on to Pennsylvania 447 North.
Like that right now, but trust me, it's not that. It's just Microsoft trying to make you Microsoft dependent yet again. So, install Anaconda, run Jupyter Labs.
Continue on US 209 North for 3 miles.
There's really no reason to stay on Jupyter Notebook when its heir apparent is there. And I say these things won't go away, won't get replaced, and the next thing I do is saying they're going away and getting replaced. But Jupyter Notebook to Jupyter Lab is like the same thing, really. They just changed the the foundation, the technical foundation, so that you could use panes, because everyone wanted to use Jupyter Notebook to create dashboards, and it was very limited in creating dashboards, and the way you had to do it were all terrible hacks. Not so with Jupyter Lab. Jupyter Lab is born to help you make, monitoring dashboards, marketing, business dashboards, native in Jupyter Lab. It's a pleasure. The Dask package that lets you parallel process under certain cases in Python. Concurrency uses a dashboard in Dask that's just magical to look at. Okay, so non-Python languages have two envies. One is this Jupyter thing that I, went on to this big tangent about. But the other is the Pandas Library. The Pandas Library is like having SQL and a whole lot more local on your machine without the tech liability of having a SQL database on your machine. It just lets you do all the joins and intersections and concatenations and, filters and stuff that are traditionally in the realm of, an installed database. With no installed database per se, Python lets you do all this stuff in memory. And right, so in memory sounds scary. Oh, you can only do as much as you have memory for. Well, that's where Dask comes in. Dask lets you take these large jobs that you can easily do that would overwhelm your local machine, and lets you, if you have it, the resources distributed over remote resources in the cloud, and just parallelizes your local Python code to just run as fast as you have nodes for in the cloud to do the actual back-end processing of a reducible task or a distributable task, a mapping to different remote nodes in order to reduce the task into much smaller bits. Map, reduce. Hadoop, my friends. Spark, but just another Python library that you don't even have to do all the Hadoop and Spark special programming. You just do normal Python and it gets all those benefits of parallelized distributed processing. But also the reverse is true. If you don't have those remote cloud resources, your money's strapped and you need to process it on your own machine, Dask will squeeze it through your local machine, doing all the memory swapping tricks that need to be done to get a too large for your hardware in memory job done. So that's not one of the points of jealousy. A lot of other...
In a quarter mile, at the traffic circle, take the first exit and stay on US 209 North.
More popular, like Java, Spark, and Hadoop. However, the database library, data manipulation library, that is Pandas, is a source of great envy from other languages. So Pandas and Jupyter Notebook are installed by Anaconda. So
exit the traffic circle onto US 209 North.
Really sexy,
Continue on US 209 North for 2 miles.
When you hear about, Python being the preferred language for data science and stuff, is because of the Anaconda install and how it takes care of all the difficult bits of getting it all running on your machine, the compiled C components that have to be in just such a place. So that's how you overcome some of the language shortcomings of Python. Install Anaconda. And I guess that's enough. I'm coming up on an hour-long video. Anyone who actually watched this, hey, kudos to you. You're my really hardcore fans. I'll probably upload this one. No reason not to. It's a lot of rambling. Let's see if I can bring it home a final point. Well, I guess it's about automation. You feel stuff out in Jupyter Lab in a web browser. You get stuff the way you want it to be. You parameterize it so that your Jupyter Notebook can be called as if it were a command line. and then you move it over to another server where you can call that previously Jupyter Notebook created in Jupyter Lab, because even though they're in Jupyter Notebook, even though you create them in Jupyter Lab, they are still .ipynb files. They're not when they're created in VS Code, Microsoft VS Code. That's a little advantage of VS Code there. I'll talk about that more later. But through an NB convert statement, you can convert your notebook into a .py file. That .py file can be put onto an automation server. That script can just be called with different parameters from there on out, according to a schedule under extremely generic Unix or Linux. There's the magic bit. This is what I'm talking about with the plumbing of technology. And if you don't have to maintain a database, you're golden. These scripts, you can have a number of them you can keep track of in your head. You can have them notify you that they're working, so when they stop notifying you, they're not working anymore. So you got a bunch of little buddy agents out there going, hey, you're hearing from us, so we're working, we're running our scripts appropriately. And then if one morning those...
In a quarter mile, turn left onto Sellersville Drive.
Your script stopped running, and you know to log into those machines and take care of stuff. So that's what I do. That's what my career has really evolved into. I used to be a pretty, I would never say traditional SEO search engine.
Turn left onto Sellersville Drive.
I created Hittail, a Web 2.0 application that's still around today. Created it with my own two hands, installed it into the co-location center at the time, and
continue for 1 mile.
And fell in love with tech and had all these abilities that let me do all these things that to other people seem to be amazing magic tricks. And so it's always kept me well employed. I've always gravitated towards where my needs seemed to be the greatest, and they've happened to be where the industry's needs have been the greatest, and it's led me to manipulating data transformations, data cleaning, collecting it, correlating it, turning it into reports. And I love it. It's a real carpenter's craft. In the old thing of the walrus and the carpenter, sure, you can become a business person and get other people to do your bidding and make yourself a billionaire, but if everything were taken away from you again, you'd have to go convincing people to do your bidding again. But if you have the technical skills, if you can sit down and start expressing yourself spontaneously in a language that machines can understand and follow your orders, you're never reliant on anyone. No vendor can really obsolete you. You can always bootstrap yourself. You can have everything taken away from you and start fresh again. And that's a really good place to be. That's where I decided to be. It's serving me quite well. And now with this crazy situation with lockdown and being able to work remotely so much, you can be anywhere in the world and do this stuff. And
in 1,000 feet, continue straight onto Sellersville Drive T523.
Where else you might be living, which used to be in the middle of New York City for me. And I don't have to be paying that kind of rent anymore. So I'm here in the mountains, in nature.
Continue straight onto Sellersville Drive T523.
Time to talk to you again, and so here I am on these commutes talking to you, and thanks for joining me, and I hope to talk to you again soon, and don't forget to subscribe.